Okay, so now we're going to look at reporting category number 5, writing exponential functions. So remember, we want to write in the form y is equal to a times b to the x. You can also think of this as your b is in parentheses. Okay, your b is in parentheses. They may not always have it in parentheses, so you want to make sure you look at x being an exponent or a power, and that base of the exponent x is your b value. So we have the population of a city is increasing at an annual rate of 4.5%. When the increase began, the population was 1,800. So again, I want to find my a because remember that is my initial value. And it says began, the population was 1,800. So my A value is 1,800 people. Okay, and what's the meaning? This is the starting population. I would write this in a complete sentence, but we just don't have enough room. So we're going to say starting population. Okay, so our rate of growth, how much are we getting bigger by? That's what the percentage is. Remember, it's the number before you add it to 100%. So it says we are increasing at an annual rate of 4.5%. So that is our rate of growth, 4.5%. You could also think of it as the decimal 0.045. Okay, so now to get my growth factor, I want to add 4.5% to 100 because for it to grow, my final percentage has to be bigger than 100%. So now my growth factor is going to be 104.5%. And I can also think of this as the value of 1.045. And this, guys, this is the number that is going to have to go into my equation. Okay, this is B right here, this decimal after we've added it to 100%. So I've got my equation, y equals, I'm going to put my starting amount in here, 1,800. I'm going to put my growth factor in here. So I'm going to put 1.045. That is my equation. And now I have an equation that I can make predictions from. But first thing we've got to do is write the meaning. Your growth factor just tells you if you're increasing or decreasing. And we're just going to say that we were increasing by 4.5% each year, because that's what annual means, each year. So when you want to talk about or describe the meaning of your growth factor, it's the percentage that you were going up by. What were you increasing by? Okay, that's how you can interpret your growth factor. All right, so now we're going to make some predictions. So I'm going to go to my calculator and I'm going to go to y equals, and we're going to type in our equation, 1.045. Make sure your exponent is a power, and it says predict what the population is in 5 years. Well, guys, if this is years, they're telling you that x equals 5 because years is how we measure time. So I'm going to go to my table, and I'm going to go down to 5, and this is, now our population is 2,243.1. But remember, we're talking about people, so I can't have a decimal. So I'm just going to round this. I'm going to say that our population, our y value, is 2,243 people. Okay, well, they want to know what is the population going to be in 10 years. So I'm going to go down. Again, this is an x value. So they are telling you that x equals 10. So let's go down to 10. And it looks like the population is 2,795.3 people. Well, again, I can't have 0.3 people, so I'm going to round to the nearest whole number person. And that means I'm going to have 2,795 people predicting. So this is not going to be exact, but our actual numbers, if we continue to grow at this same rate each year, should be pretty close to the actual population. All right, now let's look at writing an exponential function with decay. So I have a new van that sells for $25,600, depreciates at a rate of 15% each year. So again, I'm going to find my starting value, and that is what that van sells for. It's $25,600. And this is the initial cost of the van. I'm going to say new van. Okay, and I'm going to go ahead and kind of write out my equation so that I can put that in, and I'm going to put 25,600, and I'm going to squeeze that in there. All right, so rate of decay, again, that's the percentage that we are decreasing. Depreciates is another word for decrease, okay? So our rate of decay is 15%. So if I want to find B, I am going to subtract 15% from 100, and that is going to give me 85%, which I'm now going to turn into a decimal as 0.85, and this is what is going to go in my equation, 0.85. And now I need to interpret. Well, if I have a decay factor of 0.85, that means that I was cost depreciates 15% each year. That's how much value my van is losing every year. Okay, I'm going to lose 15%. So if I sell it, I'm not going to get as much as I did when I first bought it. Now what we're going to do is now I'm going to clear my calculator, and we're going to go to the table, and we're going to type this in, 25,600. 0.085, and remember, put your exponent as an x, and we're going to go to the table because they're asking us to make a prediction, and they're giving us years, so those are telling me what my x values are. So in 3 years, I want to know, what is my van going to be worth? So I'm going to go down to when x is 3, and it tells me that my van is going to be worth $15,722, and I'm going to go ahead and put a dollar sign on this because we are talking about cost. We're talking about the value. And then it wants me to make a prediction for 5 years. So if I keep this van and try to sell it back in 5 years, what is the value of my van? What could I expect to get when I sell it? So if I go to 5, it tells me that my van has a value of $11,359.